So first I want to thank the Rust Meetup group for allowing me to have a speech about a language which is not related too much with Rust. And yes, so I'm the crazy guy who invented a programming language, and probably you think of why does somebody create a programming language? And I want to explain it. So Seed7 is an extensible programming language. You can invent new statements, new operators, new everything is defined in libraries and not hard-coded. There is an interpreter and compiler. It's statically typed. You can interpret or compile to machine code, and some of the features are here. And let's move on. Why I created this. So reasonable man adapts to the world, and unreasonable persons want it the other way around. And I like this because I'm just unreasonable, and I think that everybody else does it wrong and just I do it right. So what is Seed7? So it comes and focuses on readability and maintainability. It's statically typed, as I already said, and memory saved. It's not only a language, it's a platform. So in Seed7, you can compare it a little bit with Java, which is also a platform. So I try that the same program can run everywhere, but not like in Java class files. It's more like source code portability. I have drivers I will talk about later. So the programs are automatically portable, and code can be executed at compile time and runtime. So in C++, there's this compexec, I think, or compfunc, and other languages have also, Zig, for example, has also a comp time. So I've also something like this. You can also execute the same. But it does not have, it has no preprocessor, no macros. There is no manual memory management, no pointers, and no null. So regarding integer types, you see several languages with different integer types. And in Seed7, I have the approach one size fits all. So there is just one integer type, which is 64-bit signed integers. And I don't work with all these other types of integers, so it's always signed in 64 bits. So integer overflow, as Rust developer, you probably know about integer overflow, so we'll not go into the details. If you compute something and it does not fit into 64 or 32 bits, usually you just get the lower bits, and this is an integer overflow. And interestingly, there are a lot of languages which just ignore integer overflow. And you see, they are very old languages, new languages, also very famous languages. And what all these languages do, they just ignore it. You just get the lower bits, and everything else is ignored. And you don't get any indication that your results are wrong. And I think this is a feature of these languages. So the overflow handling, you see in C, C++, Java, in all these languages which just ignore it, you can multiply two numbers, and if the result gets too big, you get something negative. And in Seed7, you either get the correct result or an overflow error, which is an exception. And in comparison with Rust, I don't distinguish between development and build, so it's always checked. So big integers, of course, if your integers don't fit in Seed7, there are big integers, and this is just to show how Java does it. And in Java, you don't have overloading of operators, so it becomes a little bit ugly. And in Seed7, we have overloading, and it looks a little bit simpler. So for strings, I do the same. I have one string fits all, and this is the second time I mention Rust here. You know about this meme about in C you have just one string type and in Rust many. Of course, I know they are all related, and there are, I think, two basic string types in Rust, and the other stuff is more made up. And of course, in Java, you distinguish between strings you can mutate and strings you cannot mutate. And in C++ you have wide strings and normal strings. And in Seed7 there's just one string type, and this is UTF-32-bit. So it can do everything. And of course, it's a little bit a waste of memory. Some people view it like this, but I think it's also an advantage if you just don't have to do this thing like do I mutate, do I not mutate, and so on. If you want to read single key presses in most languages, you need to rely on what the operating system or some libraries provide you. So you need to distinguish, am I on a Windows or Linux terminal or Apple, or is this a graphics window or not a graphics window, or am I in the browser? In Seed7 there are, as I told you, drivers, and there's just a file named keyboard, and if you read from this file, it always works. So if you are in a console application, it reads from the console or from the graphic or from the browser window. So Seed7 has drivers, and here is an example of the C code in the drivers. So you see for graphics, database, sockets, file system, console, processes, and so on, there are a lot of code, so 83,000. And this leads to portable programs. So the two examples here is some keyboard test program, and the left one is just running native from an executable, and the right one is running in the browser. And they just behave the same, or almost the same. So how does Seed7 code look like? So all the declarations have this pattern, which means a keyword, a type, then a colon, then a name, and then is, and the initialization value. So compared to several languages, this is switched. So you have this colon, and left of the colon a type, and right of the colon the name. And this comes from, like in C, you have int and variable name. So there it's also on the left. And this pattern allows that a lot of declarations use the same syntax. So you can declare variables, constants, types, procedures, functions, and abstract data type. I will come to them in a minute. And also templates, and even declarations of syntax, which I don't cover in this speech, but you can also define the syntax. And if you compare the different declarations, you see, okay, in C++ and Java, there are no abstract data types. So what is an abstract data type after all? And you see arrays and hashes, or set off, these are abstract data types. So an array has a base type, and a hash has a base index type and a base type for the values. So in Seed7, these are defined in libraries. Other languages just hard-coded this stuff in the compiler. In Seed7, it's defined in libraries. And the templates in Seed7 compared to C++, you see, in Seed7, we define a procedure, in this case declare min-max, which gets a type as parameter, and this procedure, if if it's invoked, defines the min and max function like here. So in C++, this is automatically instantiated. In Seed7, this must be explicit instantiated. You just call this function, and because you call this at the top level of your program, it's executed at compile time. So this is an example of code executed at compile time. It just declares the min and max functions for these types. And afterwards, you can just use it. The underline max 5 underline, my big integers have an underline at the end, so you can see the difference between normal integers and big integers. And parameters in Seed7, essentially you have call by value and call by reference. And if you're a programmer, in most cases you don't care about, there's just some value going into the function. And therefore, I introduced in parameters. So this is the third line, in a type name. And the type defines what an in parameter is. So for small values, like integers, this is called by value. And for bigger stuff, like strings, arrays, and so on, this is called by reference. And you as programmer, you just say in parameter, and that's it. And for 95% of the cases, this is enough. If you really want to specify that should be a value or reference parameter, you can do it as well by using val or ref. And of course, sometimes you want to change a parameter. And there are two possibilities to change a parameter. One is, I want to change the parameter in the function, but it should not have any outside effect. So this is an invar parameter. This is called by value, and I can change the parameter in the function. And the outside parameter is not affected. And the other one is the in-out, and this means, okay, I can change the value of the parameter outside, and this is called by reference, and I can do changes. And the next line is a function parameter. We will come to this a little bit later. So in Seed7 there are exceptions. So if you do something wrong, you get an exception. And in this case, we do a division. And if the division is by 0, the integer division is by 0, we get a numeric error exception. And in this case, okay, this block exception and block stuff is like a try-catch. So we execute this one line where the division occurs, and afterwards, if there is a division by 0, we catch it and write something out. And of course, we can put this code into a function. So we want that this function tells us if there was some exception. In this case, the numeric error exception. So the function is called doesRaise. It is a function which returns a Boolean. I have result variables in Seed7. So we define this doesResult, initialize it with false. And there's also a helper local variable for the outcome. So the result of this division is going to this outcome variable. And if we change, if we catch the numeric error, we just set the doesRaise to true, and that's it. And at the bottom, we see how this is used. So if doesRaise 0 or if doesRaise 1. So in the function, we divide by this parameter number. Of course, this sounds a little bit crazy, but we can do it better. So here, we, instead of just providing an integer as parameter, we provide an integer expression as parameter. So this means, compared to normal parameter, in a normal parameter, the actual parameter is evaluated if there is an expression, and the result of this expression goes into the function. But a function parameter, like it is here, means the whole expression goes into the function without evaluation beforehand, and the function can decide if it wants to execute this or not. So it might be executed once, many times, or not at all. And in this case, we execute it once in this block. Outcome becomes test expression, and there, if you look at the bottom, it is called with 256 divided by 0, or 2 to the power of minus 1. Both raise this exception. So in both cases, we can check if this expression raises this exception. But we can do better, because until now, we just checked for integer expressions. What if we have other expressions that we want to check as well? So we put the whole thing into a template. And the template is called define does raise, gets a type as parameter, and defines the function like before, just with the difference that instead of integer, there is now a type. So the type is defined by the template, and we will see later on how this works. So if we instantiate this template with the type integer and the type big integer, we afterwards can just check if a division by 0 for a normal integer or for a big integer does something bad, and the same for the power function. I said before, Seed7 is about portability. I wrote a lot of libraries in Seed7, and if you want to do something with graphics, with archives, with compression or encryptions, there are Seed7 libraries written in pure Seed7 which just do this job. And now let's go to the demo. Okay, I will enlarge it a little bit. Let's see. Okay, we start here. Okay. This is the first time I start this. Okay. It it started the program. So back to normal mode. So it started the program on my desktop. So this is just a little game, a demo game written in Seed7. So you see, okay, you can run here, and you can also dig some holes, and if a monster comes in a hole, you can put with a shovel on it, and now you beat it and get points and so on. And if you get caught, you have lost a life. Okay, this is just a demo program, and what I want to show now, I just want to, where's my mouse? Here. Okay, I end this program, and there's also a Seed7 compiler, which compiles this to C, and then the C compiler takes over and does more. So now we call this executable, and it starts very quickly, but on the wrong screen. So this is the same program as before, just now as executable binary executing. And what I want to show now is you have a browser, and Seed7 can also compile to WebAssembly. So there is the project Emscripten provides a C compiler compiling to JavaScript and Emscripten, and Seed7 can be compiled to WebAssembly. And okay. Okay. So now we have it here, and the program runs twice, once in the browser and once natively as executable. So the same program can be run in the browser. The browser stuff is larger because of the settings of the screen. Depending on the settings, you can have it in the same scaling or different scaling. And of course, you can use this same program and run it on an Apple, under Windows, and all these platforms, it looks the same on. There is also, as I showed before, this keyboard test program. So I just can put here, type some keys, function keys, or click with the mouse, and can interface where the mouse is clicked and so on. And the interface, this is the keyboard file I talked before. So your program can just check which keys are pressed, and this works under all these platforms. Okay, it's half of the time I search my mouse. So I have to press exclamation mark to stop this. And let's do something else. Here I have this is from the home page of Seed7, and I do some benchmarks comparing different languages. So comparing different languages is really, really hard because there are so many influences and so many things that make problems if you compare it. So what I have here is a sieve of Eratosthenes, and the challenge is to compute all the primes between 1 and 10 million, and afterwards counting how many primes are there. So the primes should be stored in some bit set, and afterwards they should be counted. And well, above are different languages, and as we saw here before, you see Seed7 is quite fast in this. And here is the Seed7 code for it. So it's just the Eratosthenes function, and at the bottom you see here a set of integer, and this starts with an empty set, and the Eratosthenes up to 10 million fills this set, and finally we can compute the cardinality of it. And let's see here. So I've just copied this stuff here, and now let's see. We will here. I will stop this, and a typo. So you see, it's rather quick. We can time. So it tells us the timing, and okay, it takes 0.52 seconds. And next step would be, okay, we compile it with some options to optimize. So the first option tells the Seed7 compiler to optimize the C code, and the second option goes to the C compiler to optimize as well. And now we are finished. And let's start it. It did not run at all because I need a dot here. Okay, so it's more than 10 times faster. So it's 0.038 seconds now, but we can improve on that and just do some changes here. So instead of putting this computation here, copy. We put it here. And if we do it here, we don't need it as a variable. It can be constant as well, because we don't do anything with it. So we can remove just this line. And let's see how it does now. Save. So we compile again and run again. And now it's down to 0.002 seconds, because what we do at runtime is just the cardinality of the set. So the set is computed at compile time. So the compiler computes all these prime numbers up to 10 million, and at runtime we just check how many prime numbers are there. In Seed7 we can do also other things. I mentioned before these libraries and graphic libraries, and I've here some tool, the picture viewer, and of course it lands in the, it comes to the wrong window. So this is a GIF file, and a TIFF, a PPM, icon, PNG, BMP, JPEG. And the whole program is just 300 lines of code. You can zoom in, you can move around, switch to the next stuff. Everything easy. And because the libraries do the work, you just need 300 lines of code to do this. Okay, let's go here back. And yeah, what I wanted to show you as well is here the page on the I showed before, this one. No, not this one, but this one. You see, localhost 1080 start.js. So to do this, I need a server, and the server is here, started here. Comanche is my web server, written also in Seed7. And well, if you ask why it is called Comanches, the Comanches drove the Apaches from the southern plains. So they won the war against the Apaches. So therefore I choose this name. So, and I run here, I think I run it twice. So the second one is on port 1088, and this is because I have no internet here, this is just to show my home page. let's go here. And this is also something interesting. And it should be in the browser now. Okay, a little bit weird. So, okay. What is going on here? This little program plays, it is a server, a web server. So it starts, it triggers the browser and tells the browser to go to localhost port 1081, and afterwards it does the role of a web server. So the browser goes on and requests to this port where the program answers and fills this page, sends this page to the browser, and the browser displays it. And if we press here some buttons, this is just possible if I have a mouse. So I can here scroll down. Let's see. No, okay. I searched for the P. Here's the panic again. So here's the source code of this panic program in the browser. And you can also press execute now, and as before, it starts in the wrong place. It is here, and this is the same game. Now, it is like it is running on the local machine. So it's not, as before, WebAssembly running now. It's just running on the local machine. So what you see here at the bottom is just this program. And this program, because I pressed this button, execute, executes these things. So this is running in the interpreter on the local machine now. And of course, I can terminate and exit. So let's see if I've prepared something else. Well, there is something I've not prepared, so it will not work, but I show it anyway. Go. So this is the second program, which works like this. So this is an interface to databases. It's just a proof of concept, so you can, and I've no database here set up because I set up the machine yesterday, so it's I forgot about setting up a database. Otherwise, I could demo. So this is the databases I support in Seed7. So all these drivers for Seed7, and you can just put here the user database and password, and can go log in if you choose here the right one. Let's see. Well, for the moment, I think I showed everything, but I'm not sure. So let's go back to the slides, and afterwards I will recognize, oh, there was something very, very important I forgot to show. So let's go here, slideshow, and go back. So this is how I view technology when technology involved. And it's like, first it's primitive, then it got complicated, and finally it got simple. And I think the world of software is stuck in this complicated stage. If you look everywhere, people tell you, oh, this must be complicated, and it's always unavoidable because it must be complicated. And I challenge this. I think it should be simpler. And the size of the Seed7 program you can see here. So it's not child play or so. It's really a huge project with a lot of C code, Seed7 code, and in total 630,000 lines. And here is SourceForge. So I started on SourceForge, and this is the map worldwide where SourceForge downloads have been done. Since 4 years, I'm also at GitHub, but GitHub does not provide me with such a good map to show, but I think it's used worldwide. And here is a list of people who contributed to this project. So you see a lot of people helped, and I'm searching for help as well. So if you are interested in Seed7, I'm always searching for helpers. So it's a huge effort and a lot of things to do. And if you want to come to this list, please help me. That's it. Yeah, questions?
Yeah, and how does it manage memory? Because you said there are no pointers and so on.
There is an automatic memory management. I've not provided slides for this, but at the FAQ, I try to explain a little bit about. If you look at memory, some of the memory, for example, you have local variables. So at the end of the function, you know the local variable will not be used anymore. Or you do some computation in an expression. For example, 5 times something, 2 plus, and so on. So arithmetic expression. And in these expressions, you have intermediate results. Of course, for integers it's trivial, but for other stuff like strings or so, you have the same with intermediate results. So the compiler knows at compile time when these intermediate results will be used or not used. So the compiler can decide, okay, I can now free this string because the intermediate result is not used anymore. So I have different levels of memory management. And of course, Seed7 is also object-oriented. So I have something like references. For example, files are objects. So there's file objects and so on. And there I use reference counting. So files are usually not circular. So you have more like a tree. And all the other objects, I use reference counting for that. And my idea is, why do I get rid of pointers, maybe you ask. I think pointers are like the go-tos of data. So go-tos we got rid with structured statements like while loops and for loops and so on. And I think data structures like maps help you to get rid of pointers somehow. So I've a lot of things. Does this answer your question?
But especially I was interested, like, because if we create local variables or
Yeah.
like some expressions are evaluated, we will kind of create this whole on stack memory, and it will be dropped when we.
Yeah, like.
And so for everything on heap, you use reference counting.
No. Strings, for example, are also at the heap. Except for constant strings, which are in a separate storage. What I forgot to mention, I have containers, like I told you, arrays, maps, hashes, and so on. These are containers. And in Seed7, the containers mention their content. So if you put something into a hash map, it must be copied, and the hash map has the full control about it. So if you delete the hash map at the end of lifetime, for example, you have a local hash map, and at the end of the function, the hash map is no more needed. So the hash map can itself free all its memory. The hash map does not refer outside to something else. So a hash map is a world of itself. Of course, if you put something in, it must be copied sometimes. This costs maybe performance, but on the other hand, when I free the hash map, I just can free everything without asking for permission everywhere. And for some other things, I use some tricks like borrowing. So at the time I invented this, Rust did not exist, but afterwards I recognized, yes, this is similar to borrowing. So I have some intermediate results going into a function so it borrows it and so on. But this is not memory management, this is optimization.
What will, for example, if we create a hash map, like somewhere in memory, we have to use it like for a while. So
Yeah.
it has some more complex left-hand than just
Yeah.
like from end to the beginning function. So if there is no garbage collector, so the compiler at compile time decides when it will be dropped.
Yep. The compile time, so if you have a local hash map, the compiler knows at the end of the function, I can free this hash map. So the compiler, for every type of hash maps, the compiler creates functions in the C code which can free this hash map. And for every type, for arrays and so on, for every type, the compiler creates special code to free these bigger structures. So and these functions to free some hash code or map or whatever is called at the end of the function, so the compiler already knows now can I free it. So no runtime overhead because of this. So I have no garbage collector process. Yes?
What happens if I put a file in a hash map or in a map?
A file is a reference, is an object. So you just have the object, and the objects use reference counting. So in this case, you just have the interface to the object, and therefore, if the map frees this file, the reference counter goes down, and at 0, the file is freed. Yep. So all this stuff, like in many programming, you have trees or so. I don't suggest using trees and implementing them itself. I suggest implement something using arrays, hashes, and other containers. But of course, with object-orientation, I can build trees, but I cannot build circles and so.
Like kind of circular references.
Yeah, if you have a circle of reference, the reference counting will not work.
Yeah, so it is not possible to create circular references.
No, you can do it, but you will have leaks in the memory. So usually I don't use it. So if you need to use something like that, I suggest using containers instead. So it's like you don't use gotos, use while and ifs and so on, and don't use pointers, use containers. Something else?
Yeah, actually about exceptions, I was interested, like, so there were like try catch.
Yeah.
There is some runtime that like kind of throws.
Yes, yes. There is, how it is called, the simple C++, how it is called, long jump, set jump. This is a basic functionality in all this in C, coming from C. So you can store the current with this set jump. Yeah? It stores the current position at the stack to some variable. And if you later on say long jump to this, what you store to this variable, it jumps back to there. And this is used in C++ as simple implementation for exceptions, and I use it as well. Okay? Any other question? Okay, so thank you.